Okay, so good morning to everyone and welcome to the INNOMEM Open Call Webinar. My name is Filipa. I'm the INNOMEM Open Call Manager. I want to thank you all for joining us today. The reason we are organizing this webinar is to present to you the INNOMEM project, along with all the services and all the technical infrastructure that INNOMEM as a project is making available to you, the community. And the way that you can access those services is via the open calls, which is what we want to present to you today. Let me start by showing you the agenda. We will start with a welcome message by John Zuniga, our coordinator from Technalia. And then we want to show you a short INNOMEM video with a presentation of the project. And then we will move to the pitch presentations of the INNOMEM applications and all the available services. We will end with an overview of all the application and selection process. And then in the end, there will be room for questions. John, the floor is yours.
Thank you, Filipa, for the introduction. Good morning to everyone and welcome to this webinar. For the ones that don't know me, my name is John Zuniga. I'm the head of the Membrane Technology Department at Technalia and the coordinator of INNOMEM project. INNOMEM is an open innovation testbed funded by the European Commission, where basically we are developing membranes and membrane-based services, technical and non-technical, that we have been developing for the last 2.5 years, and we want to introduce this to you and offer services through the open calls. I hope you enjoy the webinar and hopefully you will apply.
Thank you, John. So now I will resume sharing and I will show you the video.
Good morning, my name is John Zuniga. I'm the head of the Membrane Technology Department at Technalia, and I'm the coordinator of INNOMEM. INNOMEM is a EU-funded project mostly related to membranes, where the aim is to create an open innovation testbed and become a one-stop shop for any company in Europe which has problems related to membranes. Now we are in the middle of the project. We have been working on the optimization of the pilot lines and debugging all the technical and non-technical services, and now we are ready to provide our services through the open calls. If you have any doubt, do not hesitate to contact me.
For presenting this first workshop. The main aim of the workshop is to describe the main achievements that in the project we obtained during this 2.5 years of activity, in particular for what regard the most promising and breakthrough manufacturing pilots, the advanced characterization technique and modeling that can be then used as services in the project.
So how exactly can INNOMEM help you with that? So basically, through this SEP, we will make available the facilities and the services. We will make them available through the SEP, and you can just get access to them by applying to the open calls. So this will allow you to develop, test, and adopt the novel nano-enabled membranes in a very cost-effective and sustainable way. And what we really hope is that it opens up opportunities for demonstration of the innovative nanomembranes in real-life industrial problems, like John has also mentioned, and potentially accelerating the market opening for these new products. The way to do that is really through applying to the open calls and have access to the services and to the facilities.
Okay, I hope you enjoyed watching the video. You got to see some of the INNOMEM partner faces and some of our available facilities and infrastructure. I now have to stop this. And we will now move to the pitch presentations of the services by our partners, and we will start with John from H2 site.
Okay, good morning, everyone. My name is John. I hope all of you can hear me well. Yeah, I'm from H2 side. So H2 side in this project in INNOMEM has worked, let's say, as an end user of kind of end user of this INNOMEM service. So I will give an example from our need or the need of H2 side, which was the starting point, and how was the development of the project for us. And I hope that this could be a good example for third parties to apply for this open call. So if you can flip move forward, please. So why INNOMEM for us, or for H2 side? So I mean, my company wants to sell systems for hydrogen production. Okay, starting from biogas as a feedstock. Okay, how we can produce this hydrogen, or how we can produce and separate this hydrogen. Okay, using palladium membranes technology, which is a validated technology, but the issue is that every equipment must be designed and built depending on the application and working conditions. Okay, so there are some issues related to every application. Okay, so for us, our need was to validate the performance and construction for our system, targeting a particular application, which was biogas reforming, and which could be these issues. Okay, related with security, with the heat integration, with the design and the modeling of the reactor, also with ATEX and CE marking. So this is why we joined the project, in order to use the services of some entities here in INNOMEM. Okay, if you can move forward. And before explaining a little bit more, I wanted to show which was the TRL we are talking about. I mean, this is our system, the final product or the result of the INNOMEM project. Okay, so we built this system in INNOMEM. Okay, for producing 2 cubic meters of hydrogen with purity higher than 99.9. Okay, and this is a 20 feet container, let's say, or system to be integrated in a 20 feet container. So this is the type of TRL you could expect from this application, which I will repeat again, is gas separation to obtain hydrogen. Okay. So, well, as I said, it's hydrogen production from biogas stream. Sorry, it's a stream, no steam. Okay, and we had particular goals, which, okay, to the system to be proven in a test campaign for more than 100 hours, to reach a certain production, and also with a certain purity that I already said. And we work together with Tecnalia and University of Eindhoven in this particular case, okay, because of their background. Okay, in the case of Tecnalia, which is the definition, we used Tecnalia, we worked together with Tecnalia to define, fabricate, and characterize the palladium membranes. And also we worked together with University of Eindhoven on the design and the modeling of the reactor. This could be the big picture, okay? But if I go more into the detail, so you can see particular examples of how we develop the project. If we go to the next slide, here are the let's say the detail or the main works or the main developments we carry out with both Tecnalia and the TUI. Okay, so in the side of the membranes, okay, we were able to define the membrane properties and the quality standard. Means the alloy of the membranes, also thickness, size, the selectivity we were targeting. Also, once we performed some membrane fabrication, we had to characterize and validate the performance of these membranes. So some tests in terms of to obtain the permeation, selectivity, also composition and thickness were performed by Tecnalia. And at the end, Tecnalia fabricate the membranes that finally were integrated in the reactor according to the starting point. Okay, and on the other side, the work we performed with the TUI, with the University of Eindhoven, was let's say on the reactor background. Okay, which for us means the modeling of the reactor kinetics and performance. I mean to fix a purity we need and the expected recovery, and in function and depending on that, we were able to define the membrane area we will need to put into the reactor, also the operating conditions to get this recovery and purity. We were able to design the reactor configuration, which was a fluidized bed membrane reactor. And of course, some of the materials and the equipment to place in the reactor. And we worked together with them on the safety analysis and also on the study of some CO sorbents for the hydrogen purified stream. So this is the example of the work we did together with Tecnalia and the TUI, and these are the kind of services you could expect from these two entities in the scope or in the field of hydrogen separation from palladium membranes. And well, finally, some of the takeaways for us after this project, or the valuable takeaways, was that, I mean, what we realized is Tecnalia and University of Eindhoven have a very broad expertise on the palladium membranes field, and also in the membrane integrated reactors with applications for generation and separation. Of course, I mean, palladium membrane technology has multiple applications, and each one needs a very specific working conditions, and every reactor must be designed according to these conditions. And for us, the results we obtain, or the results of the performance of this demonstrator, were very useful for us to get in touch with potential clients of this proven application. And that's all from my side. So thank you.
Okay, thank you so much, John, for your really interesting presentation. I think it gave a good overview of the potential applications, even for other companies interested in this field. I will now give the floor to Kira from Twente.
Thank you very much, Filipa. I hope everybody can hear me because I had some technical issues starting up.
We can hear
Great,
you very
thank you. My name is Kira van Dijk. I'm working at EMI Twente as a research assistant, and we are located at the University of Twente, working closely together with the membrane group here. And we as EMI do contracted research on behalf of mostly industry. And we do different researches in the whole membrane field. So we can do research in the hollow fiber industry or flat sheets, electrodialysis, and then, for instance, gas separation or water separation fields. So we do from beginning to end the whole membrane industry. You can go to the next slide, Filipa. We are equipped with different hollow fiber spinning machines, from a small scale to a very large scale, pilot one. And within the INNOMEM project, we upgraded our pilot system, our hollow fiber pilot system, with an inline electron beam device. You can go to the next slide. And with the electron beam device, we put after our rinsing bath from the pilot line, we can do some functionalization of different membranes, hollow fiber membranes. Such as cross-linking the polymers are a different chemistry that you can put in your dope or bore solution. You can do a surface modification, or do functional molecule or enzyme linking onto your hollow fiber supports. We can put it inline, so directly placed after the water bath, so it's within the spinning machine, but we can also use it as a standalone machine. And then we can use it static or dynamic, so we can put a pulling wheel behind it, so we can guide fibers through outside of the line, but we can also put fibers or maybe flat sheets within the e-beam and test it static. You can go to the next slide. I think it's then, yeah, that's a picture from the e-beam, yeah, after the rinsing bath and then for the before the winding wheel. And then the next slide. As we are a company doing a lot of different research within the membrane industry, we have a lot of extra services that we can provide. We can do big projects as membrane development, but we also can do some smaller projects as characterization projects. We can help you out with a lot of different things. The next slide. If you want to know more about our EMI or the project, you can contact one of us. Helene, Herman, and I are working within the INNOMEM project, or visit our EMI Twente website, or send an email to our EMI Twente email, and we can help you if you have questions. Thank you.
Great. Thank you so much, Kira. I will move now to Zansat.
Yes, hello.
Hey.
Yes, good afternoon, everybody. My name is Zanchat. I'm from the Eindhoven University of Technology. And today I will give a short presentation on the virtual lab for modeling. That is a service that is provided within the INNOMEM consortium. So what is the virtual lab for modeling? The main objective, it's basically a huge database of all the modeling capabilities of all of the partners within INNOMEM. So its main task is to assign the most appropriate partner or model to any single user request that might be needed for modeling. So if you are a partner, or if you are any customer that is looking for a specific modeling application, but you don't know who to contact, this database can be a nice tool for you to connect to the right partner, which has the right type of software and the right type of model application that is suited for your request. And lastly, of course, the virtual lab is important in facilitating and supporting all of the activities that are also being done within INNOMEM itself and within the showcases, as, for example, John in his previous presentation already highlighted. So what is inside of the database? So the database consists of a list of information per model and per partner. So you have the partner information, the type of membrane operation that is modeled, the type of modeling software, which can of course be important if you want a specific software application for your user request, be it in MATLAB or ANSYS Fluent, for example. What type of capabilities the models have, so the strengths and the limitations of the different models, which might also be useful or good to know for your application. The scale, of course, you can go from molecular scale all the way up to a full industrial plant. You have different kinds of models. The target application, is it membrane reactors, gas separation, pervaporation, etc. The input and outputs of the model, the integration possibilities with different models, and lastly, of course, the computational time, which is crucial because the more advanced and rigorous models will take a longer time to run. And of course, time is money, so that's also something to consider. The procedure to use the virtual lab, in principle, if you have a user request, for example, you want to model ultrafiltration membranes, or you want to have a certain design and you want to use a model for this, you can get into touch with, or you can use the virtual lab, which has this database, and it will search for all of the partners that are connected to this database, and it will connect you with the most suited partners that can handle your request in principle. Next slide, please. Yes, and an example you can see here. So for example, if you have the model criteria gas separation with a MATLAB model, it will, as an output, the virtual lab will give, for example, TOE or CNR and all of the partners that match the criteria and the specific models that you want with the contact details of that partner. So you will be put in touch with that specific partner to discuss that project in more detail. Here you can see an example of, in this case, the different procedures per all of the partners within INNOMEM. So on the left, you can see the membrane reactors, gas separation, all of the different applications, and you can see which of the partners have models for this application. And of course, for multiple of these characteristics, there are tables, and that is how the database is built up. Of course, we've done some dissemination for this virtual lab, and this webinar is one of them as well. On the left, you can see the LinkedIn page where you can find more information, and more importantly, on the right, you can see the INNOMEM website itself, which also hosts a page for this virtual lab where you can read a bit more about it. And you can contact me or Fausto Gallucci from TUE to make use of this tool and get into contact if you have any specific model or request. I think, yes. So yeah, thank you for your time. And if you have any questions, feel free to contact me or go to the INNOMEM website for more information about this. Thank you all very much.
Thank you so much. Really inspiring. I hope everyone was inspired by your talk and got to see the opportunities that are here in your lab. I will now give the floor to Victor from LICTEC.
Yes, can you hear me?
Yes, we can hear you, but not see you yet. Yeah, now we can.
Now, okay, perfect. I thought Adele was before me. But okay, then okay, my name is Victor Candelario. I'm from LICTEC. You can go to the next slide. So I will present very briefly our company profile. We are manufacturer of silicon carbide membranes. We produce membranes, ceramic membrane for micro and ultrafiltration. And at the same time, we also produce diesel particulate filter and gasoline particulate filter for silicon carbide. So then we produce the entire system, and we also have 2K water treatment. We can use our system as a pre-treatment. We work directly together with micro, ultra, nanofiltration, and reverse osmosis filtration, and we install and commissioning all the system in the factories. You can go to the next slide. In INNOMEM, our task is two showcases. I will present a bit briefly both of them. One is regarding membrane, and the other one is regarding the particulate filter, gasoline particulate filter. Okay, so the first one is showcase one, is together with Vito in Belgium. And one of our advantage in the silicon carbide membrane is the high permeability, high selectivity, is chemically and thermically resistant, and it's stable in operation. It has a very high durability. But the disadvantage of the ceramic membrane, and mainly the silicon carbide, is the fouling tendency. So this is something we have to solve in our application, and the way to solve it is doing by the grafted membrane. So grafted will be done in Vito, and it's a system for chemical functionalization of the tubular ceramic membrane. And this chemical functionalization is in the full porous surface of the membrane, and the top layer can be beneficial for further increase the membrane performance. And in this case, it will increase the anti-fouling properties, so then it will decrease the fouling at all. So it's our goal here in this showcase. You can move on. So the way of doing the grafted, it will be done by getting grafted. Is already patented by Vito, and it has a unique bond, directly metal functional group with the R group, and we will change the surface charge. Now our ceramic membrane is positive, and we will go to neutral. So then it will not be. We will remove the addition of the fouling. So then it's a high stable bond. It's relatively simple surface chemistry. It's not very complicated, and the method allows to high flexibility. So we can try different functional groups, and it will increase the anti-fouling properties, and it will fit mainly with all the solvent, with some limitation in pH. But as soon as we are inside the limit, everything will work perfectly. You can go to the next. So the membrane used for this showcase and for this special application that I will present in the next slide, it will be our ultrafiltration membrane from Lichtech portfolio. And this membrane is made by a silicon carbide support with a porous size around 50 micrometers, with a top layer made by monoclinic zirconia membrane. This is stable in pH because it's monoclinic, so we don't have the problem in the acid pH. And as you can see in the CM picture, it's quite homogeneous and defect-free membrane. The porous size of this membrane is in the range of the ultrafiltration, is more or less 60 nanometers. Next slide. For our showcase, we select a feed from oily water, so it's an oily wastewater stream, and you can see the picture is quite white. So there is an emulsion of oil, and it has a very high amount of heavy metals because this is used in the machinery of metals. So there is a lot of heavy metals that we have to remove because of the legislation. And it also have a high COD and turbidity and mineral oil. Can you press? So a way to remove this or to break this emulsion, it will be by coagulation. So the first step before filtration, it will be to coagulate our feed, and this is done by iron chloride. And then doing that, we can decrease the the heavy metal content and decrease the mineral oil content as well, and the turbidity and so on. Then our real feed for filtration, it will be this coagulated one. Next slide. Then if we compare native membrane and the grafted membrane, in the clean water permeability, we can observe that there is an increase in the permeability, so we get a more hydrophilic membrane. This is also important for us in the way of the filtration, and during the test we can check that the permeate doesn't change too much. So then we get the same performance in filtration for both membrane. But for example, when we have to select the critical flux, and this is in the graph, we can see how it's more stable in the grafted. So that means we need to choose higher flux to perform the filtration. This is important for us because then we can do the filtration of the feed with a small surface area. So then we have to use less membranes to perform the same filtration as in the native. So this is something very important for us, and this is because of the anti-fouling properties of the grafted membrane. And then we will have to clean less the membrane, and the durability of the membrane will increase. So using the grafted membrane, we can increase the performance of this specific feed, and this is very difficult feed. So more or less, this is for the showcase one. And now you can go on, Felipe. Now I will present very briefly the Showcase 5. Showcase 5 is for gasoline particulate filter. Is mainly to purify the exhaust of the gasoline car and gasoline motors. So usually what we are doing nowadays and is in the market is our DPF is with a square channel. And the problem here is that when we try to incorporate the catalyst coat, we don't get a even coating. So because of the how it's in the picture B, I cannot I cannot show it, but in the picture B you can see how you have a more accumulative in the corners. So you can go the next slide. So a way to solve this is trying to do it a circular channel. This is more complicated to do it in a normal monoliths, and also using hollow fibers we can increase the surface area. We will remove these square problems, and also we can attach a lot of hollow fiber together. So the goal of this showcase is to produce hollow fiber ceramic membrane. This is made by a ETA stabilized zirconia, and is a microporous with porosity with high open porosity inside the hollow fibers. So then all the hollow fibers will be attached together and designed for the exhaust. You can press. So the way to do it is we incorporate in these hollow fibers 3 different coats with 3 different precious metal. For the confidentiality, I cannot say which is one, but we got the result that using one of them, we can decrease a lot the light of temperature at 160 grades centigrade. Usually what we get with our standard DPF in the square part is around 300 something. So we decrease the temperature like 200 degrees. So this is a quite important achievement during this showcase. And also we discovered that the loading of the coating, it was not there is not effect. So we tried different times, different coating time, if we can call it like this. But once the hollow fiber is saturated, we don't get any improvement. So then we can also, in this way, we can also save some of the catalyst that is quite expensive. And then in the right of the slides, this is the way we are assembling the hollow fibers. So we measure the exhaust, and then we assemble them to get the shape that we need in each motor. So then it's a way to optimize the hollow fibers and optimize the catalyst. So for us, it's quite important this showcase as well to demonstrate how it's improving when we have this hollow fiber instead of the square. And that's all for me. If you have any question, I think we have time in the end, and you can also write to me. Thank you.
Exactly. We will have some time at the end for questions. So thank you so much, Victor. So we've now did a lot of the 4 of the pitch presentations on the technical services, and what we want to show you now is the non-technical services that INNOMEM offers. And we will start with Unai. Hello.
Hello, my name is Unai Calvar and I work at Tecnalia Ventures. Next slide, please. Yes, through INNOMEM, we'll offer business services related to defining the value proposition and unique selling points, preparing an elevator pitch, and developing a market roadmap. Next, please. When we talk about defining the value proposition, we mean identifying a problem in the market and providing an adequate, attainable, and profitable solution to this problem. Next, please. We will provide guidance in preparing an elevator pitch, from identifying a problem in the market to preparing a proposition for investors. The preparation of the elevator pitch will vary from project to project, and we will focus on the most relevant aspects accordingly. It is important to note that the questions we will need to answer in this elevator pitch can serve to self-assess our project and to try to convince others of the validity of a business proposition. Next slide, please. When developing a market roadmap, we will identify the main objectives within the project. We will then establish the milestones that need to be fulfilled to achieve those objectives. And finally, we will set a traceable action plan for each milestone. Next, please. And finally, just let me tell you that I'm open to any questions or comments you may have, both today during the workshop and later on by email or whatever. Thank you very much.
Great. Thank you so much, Unai. And our last pitch is from Marco Colella.
Yes. Hello.
Hi.
Hello. Thank you. Thank you. So I will try to be fast. So if you can go to the next slide, please. Yes. So in synergy with what my colleagues from Tecnalia Venture, I'm Marco Colella, by the way, from Pioneer Consultants. So we are an R&D and advisory and grant consultancy. I indicated these services as innovation services just to give a little bit of the difference from the standard business services. So basically, these services are related to three main needs. Understanding a little bit your market, which is related to your project, especially if you're entering a new market and you are uncertain about the mapping that you have of the current situation. Then grow your network inside that market, which means finding collaboration or even customers, right? To better promote your project and scale it up to the next level. And then, of course, develop a financing plan, especially based on the on public funding. If you may go to the next slide, please. Thank you. So, for example, know your market landscape. What we do is that, and we do it for international clients usually, we deliver a market and technology trends analysis. So it's a mix of economic and technological information that we put together, looking at a lot of different data, such as, for example, patents, of course, but also R&D collaboration on a global basis. And with these services, we can tailor an analysis on your specific project to better understand the state of the art, to map the market and the technology, to understand where are the key leaders, the key players, and provide you a full picture, also consistent with the current EC policy and regulation that will somehow push the product's development in one direction or in the other. On the other end, we also looking into investment data, which means that we also able to provide in the picture who is actually investing in a technology, either developing or just financing it. And then we can go to the next slide. Thank you. So the next step is also not understanding who is doing what, but also how these organizations in the market collaborate. So by collecting this information, we can do basically two things to scale up your project. First, completely mapping the network of collaboration related to a certain segment and try to understand so who is actually developing, who may be interested in using a certain product. So this will in turn help your business plan or also your elevator pitch as presented by my colleagues before. On the other hand, you maybe need to solve some specific solution outside what my colleagues from the pilot line can give you. And whatever your need is, we can scout the optimal provider or the optimal collaborators. And then the final slide. Thank you. And then finally, if you want to scale up your project and you want to understand, okay, now we have delivered you have applied to the open call, your project is fulfilled, and now you need to go to the next level. You maybe need further funding. So we will be happy to support you in breaking down your project, imagining like it could scale up, and based on that, giving you a picture of what is the funding landscape that you can deploy, both at national and at the European level. And that's it from my side.
Okay, thank you so much, Marco, and thank you to all the speakers of the pitch presentations. So I hope you got a good glimpse of the services that INNOMEM can offer. And what I want to present to you now is really how you can get access to those services via the open calls. So let me start by telling you what the open calls actually are. So imagine you're a company and you're looking for a better and novel solution to improve your operations and your business using membranes. Then INNOMEM is the one-stop shop that can give you the best available experts and the best technologies that cover the full value chain of products based on nano-enabled membranes to address your needs. And that's really the objective of the open calls. They are a tool that will enable you to get access to this one-stop shop for free access to the facilities and the services that will be provided by the INNOMEM partners. As a project, we've allocated budget specifically for the open calls. And so any interested companies and industries can make use of the services offered by the partners. The call will be open until the end of January this year, and applicants can apply at any time during this period. All submitted proposals will be evaluated only following the cutoff date. So as I said, the calls are open to SMEs, startups, and large companies. So for all the universities and research centers that are attending this webinar, we welcome you to invite the companies that you work and that you collaborate with to apply to the open calls and make use of these services. So we invite industries that are innovating in novel technologies in the field of, as you also saw in the pitch presentations, liquid gas separation, water treatment, hydrogen purification, CO2 capture, just as examples of applications using these nano-enabled membranes. And these can be industries that can act in the sectors, in environmental sector, health, energy, but of course, all other companies are also very welcome to apply. Important to say is that if you're a company, you're currently not using membranes in your operations, or you don't know if these membranes would be suitable to improve your processes, you should know this is also a service that INNOMEM with these open calls can provide. So you can simply submit a proposal to assess whether any of the technical services we have is suitable to your current processes, and we can make this evaluation together. So it's an easy and straightforward way to see if any of these innovations can also be applicable to your innovations. So all successful applicants will receive access to the INNOMEM services. So you will not receive any funding. You will receive the free access to the services fully paid by the project. And the services that we provide can be either in a small scale, so maybe a service that can last up to 1 month, or even a large-scale project up to 6 months, where you can use a combination of the services we provide. Maybe you want to use some of the non-technical services that Unai and Marco presented, assess your a funding strategy, a pitch presentation, commercialization strategy, and maybe you want to combine that with some of the technical services using our pilot lines and facilities. This distinction is important for the submission, because for the large-scale projects, we ask for a bit more information than for the other two. In this figure, we summarize the full process from the preparation and submission of the application until the end of the service delivery. So you start with preparing a very short application. You can find all the application documents in our website that you see here below. And you can be supported via our help desk throughout the whole process. You can contact us if you have any doubts with the documents and the application. Then you can submit it via our platform until the cutoff date. It's 31st of January. After that, we will start the evaluation and selection procedure, which should last approximately 1 month. We will have evaluators with both the technical and the business background, and the criteria will be based on the excellence, impact, and implementation of your project. And at the end of the evaluation and selection procedure, all applicants will receive an evaluation summary report. All successful applicants then will receive service planning. So the service delivery manager from INNOMEM will send offers to you. So you've during your application, you've pre-selected which services you want to use from INNOMEM. And as a project, we will tell you what we think our best offer is from all the available facilities and experts that we have in the project. And then the negotiation phase starts. So we say, these are the services we think could be suitable to you. And then we discuss in collaboration what would be the best fit. After this is decided, a demo case collaboration agreement is signed, where also all the IP arrangements can be agreed upon between the two parties. And after that, the service delivery can start. And then the execution of the services can last between 1 and 6 months, depending on the type of project. And at the end, there will be also a final report on how the delivery of the services was. Here you can see an overview of the application procedure. We saw some examples here in this webinar about the services that you can access, but with the project, we really have many more services. So we invite you to browse the catalog of services that we have available via this website to really see the full range of services and infrastructure and pilot lines that we have available for you. So this is really the first step before considering applying. Go have a look at all the services that we have summarized in our catalog of services. Also, if you have any doubts regarding the services, you're very welcome to contact us and we will answer your questions. After that, you can visit the Open Calls dedicated website. You will find the application form, also the full guidelines and the evaluation procedure, and also a list of frequently asked questions that we've compiled based on some feedback we've received since the calls have been opened and that we want to share with everyone. You can then download the application form, complete all the sections, save as PDF, a maximum of 5 pages, so very short, and then you just submit it through the INNOMEM website. This is how the website looks like. You just need to complete some of the details on your institution and on the applicant. We also want to know how you heard about the INNOMEM Open Calls, and then this is the place where you upload the PDF file. So very simple, one step, just upload here and then submit. These are the supporting documents that you can read. So like I said, the guidelines, the form, the evaluation procedure, also the demo case collaboration agreements, a template that you will sign once the service, before the service delivery starts, and here the frequently asked questions. I want to briefly show you an overview of the sections of the proposal that you have to complete to apply. It's divided in 3 sections. Section 1 on the concept and the challenges, where we want to hear about the objectives of the project, what the ambition is, and also the description of why you need the INNOMEM services. Then on section 2 on the impact, we want to know about the industrial relevance of your innovation, what's the technology readiness level positioning, the market and the envisioned commercialization strategy. And then for large-scale projects only, we also want to see how you envision combining all the services that you are requesting, how you plan your work, the key deliverables and milestones, and a timeline. I also want to point out that we have the contact help desk button here that will direct you to this help desk email. And I strongly encourage you, if you have any doubts, to reach out to us and we'll do our best to clarify your questions. And with that, I want to thank you for your time. So all the presentations are finished now, and I would like to open the floor for questions if there's anyone in the audience that would like to know more about anything we've presented. Or any other comments if you don't have any questions. If there are no questions, John, maybe you want to say some final words? Oh, we have one question here. So we have a question or a comment, very impressive capacities. The question is, who exactly are the target clients of the consortium? Are membrane manufacturers the main targets? And the second question is, when will be the second round open for the INNOMEM Open Calls? Good program, but it's already 16th of January. John, do you want to go with the first question and then I'll answer the second? You're muted, just so you know.
Can you repeat the first question, please?
Yes, so the question was, who are the target clients of the consortium, whether it's membrane manufacturers?
Okay, not really. The aim of the project is that anyone with a problem related to membrane can find the place where to make a question and get an answer. So of course, memory manufacturers, it's direct possible customer, but end users could be as well. Polymer material manufacturers, engineering companies, anyone with a request.
Thank you. Regarding the second question, so the second round will open in spring next year. The exact date is still to be confirmed. We anticipate it will be somewhere in May, but we will release the dates as soon as possible. We know it's only 2 weeks until the deadline, but please have a look at the application beforehand, because it's really very simple. 5 pages is the maximum, so if in 2 pages you can say what you need, then this is also perfectly acceptable. So I encourage you to still apply in any case. We have here a question on whether Swiss startups are eligible to apply. Unfortunately, no. Another question on the IP generated during the accepted calls, whether there's a general policy of INNOMEM. Maybe I direct this question to Unai.
So this has been a theme for discussion lately. Basically, there is an agreement that is signed between the applicant and the consortium, and that's publicly available. And there's also information on that on the frequently asked questions. And to answer your question very briefly, the basic principle is that a company coming to INNOMEM with their own IP will retain the ownership of that IP. If any further developments are done on that IP, that will be owned by the initial owner. If any joint development is carried out through the project between the pilot line owner and the applicant, there will be an initial agreement on how that ownership will be parties. But however, the basic principle is that the IP will be owned by the applicant or the company unless otherwise agreed with their counterpart. I hope I made myself clear, and I hope you understood.
Yes, I will just repeat what you just said because the connection was a bit unclear. So generally, in principle, it's owned by the applicant, so the company is using the services, unless otherwise agreed. And the time to make this agreement is before the services are delivered when you sign the demo case collaboration agreement. But in principle, it's by the applicant. Then we have a next question. All companies, including public water supply facilities. I'm not sure whether the question is if these companies are also a target of the INNOMEM services. Yes, any industry covering any private industry that is dealing with water supply could also be eligible to apply to the calls.
Yeah, so basically an utility. I understand it's like an utility, so
yeah,
of course.
Exactly. Then we have another question. As the work will be publicly funded, whether the results in the proposal need to become public. The answer is no, in principle, no. So this is a service agreement between the INNOMEM project and partner and the company that is requesting the service. So the results and all the confidential results that will be generated do not need to become public. John, you can confirm this, correct?
Yes. Just also let me say from the perspective of we have some deliverable where we have to report, which are confidential, by the way, when we have to report about the demo cases. But first, it's an internal. Second, in that deliverable is not expected to release confidential information. It's just the reporting of the activities to keep track for the European Commission, of course. But it's a different thing.
Thank you. Then we have another question on whether this platform can be used to develop the startup, meaning whether the startup needs to exist and be registered beforehand and then only be developed. This is a very specific question. We have some criteria for these cases, I think, in our application documents. In principle, you should already be an established company. to be able to apply. This is one of the requirements. But this is such a particular case that we will get back to you with a more concrete answer, because if this is really in between steps, there may be an exception we could make. Marco.
No, I don't have an answer. I would say that we could support that, but that you have a legal obligation to have some legal entity. So we need to look carefully at it.
Yes. Yeah, we will get back to you. We have your contacts through the registration link. Okay, we have more question. Is there any interest to involve universities and research centers to test the developed membranes in other applications not foreseen by the partners of INNOMEM?
Maybe I can take this one, Filipa.
Yes.
It's an open innovation testbed. So now, as a European project, let's say it's something closed. So we have the open calls, but the consortium it's established and the money was given. But the aim of as a open innovation testbed is that it grows. It will be something alive, and that actually we want to make it sustainable. This means economically sustainable in the future. So it will be open for people to join, for partners to join, for partners to lead. So the answer is yes, it can grow in the future, and we want to make it as powerful as possible.
Great. John, this is a really good invitation for any other partners also attending the webinar to contact us and reach out for any potential synergies.
And not only for universities or RTOs, also companies can provide services through the Open Innovation Testbed in the future.
Okay, we still have some minutes for more questions. And we have another one. Oh, we have a congratulations on the project also. And the question on whether do we have a possibility to apply to find membrane-based solutions for specific water treatment or chemical treatment problems?
Yes.
Yeah, the answer is a clear yes. And you don't have to know exactly which is the best membrane-based solution. This is also a question you can ask us. So you come to us with the problem, and internally we try to find a solution and then tell you what the offer is before we do the service delivery. So the service delivery planning phase is really to try to find the solution that fits best to the problem that you're presenting. So the catalog of services is a good way for you to have an idea of what type of services we may provide. But if you're unsure, you can. We will also be happy to help you with identifying the best membrane-based solution for your problem.
If I can add, Filipa,
Yeah.
I invite everyone to send the request. In the end, the worst that can happen is that we don't know. That will be the answer. I mean, this is quite a big consortium with many good membrane groups inside, but maybe we don't know. So that can be also a possible answer. And in that case, we won't be able to provide a service, but you will get the answer. And also it will help us in the future to try to develop also the capabilities we have or invite other partners.
Indeed. But in principle, INNOMEM really gathers the experts in Europe in this field. So we hope we will be able to get you a solution. And like John said, if we don't, we will try to direct you to any other partners. Okay, I think there are no more questions coming in. But our contacts are available, so you are very welcome to reach out to us and visit the INNOMEM website and the Open Calls website to get to know more about the project. Feel free to reach out to us. We'll be happy to even schedule a follow-up call if you want to know more about how to apply in direction to your specific application. And we will also send you the recording as soon as it is available. Thank you very much. Have a great day.
Thank you very much. Thank you, Filipa.
Thank you. See you
Thank
soon.
you.
Thank
Bye.
you.
Nice day.
Bye.
Thank you, Filipa. Bye-bye.
Thanks.
Bye.